Hi, son. Congrats on the first. You should have paid Spetri the $5. Okay. There's a thing in the Discord, right? Okay, good. Well, not good, but also good. Okay. I wanted to do linear algebra today, but I left this question unanswered from the mechanics textbook, and it's kind of bothering me. So I think maybe I'll do this question and then I'll go to linear algebra. Um, okay, and so R. I don't. Well, do I want that? Maybe I do want that. Oh, you're not supposed to be playing Kendrick right now. That's what you're supposed to be playing. Okay. Um. Ba, 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 ba. How's Dom? I don't know. You should try asking him. That one was on purpose. Sure. It's not because the M and the N keys are right next to each other. I'm a Dom. Oh, am I a Dommy mommy? Is that why you call me mom? You have to explain everything. Apparently, you do. Pretty good. I had some Welsh jackass blowing up my DMs, but other than that, it was good. uh, I make myself laugh. Um, what am I doing with this? I have to bully you because it's fun. That's why you're so sensitive. I was gonna do something weird, but maybe I should do something weird still. What if I just um I just want to set up an integral and see how I feel about it. Um, how do I feel? I guess if I start at the top, and I'm integrating in y here. I'm kind of thinking of this integrating from the top down to the origin. Um, I want the circumference of each of these rings. And so it's 2 pi r, but r we can express in terms of uh, this h and this r. Why am I vandalizing that umbrella? Because it's a stupid umbrella. And so, um, where am I? Actually, I guess this is just y. I don't need to make that h. So hypotenuse is big R minus the other side of the right triangle is y squared. And so y starts equal to r, and we get 0 from that as expected. Good. Now this integral would give me an area, which I think is what I want. It's a mushroom? GF. Levy, a Hamel basis? I've never heard of that in my life. Infinite dimensional vector spaces. Vector space over Q. What is a basis? Okay. Now, I feel like you will be best... if that's the question, you'd be best off going to the fundamentals of linear algebra before trying to get into this specific stuff. But a basis is a question I actually can answer. A basis, talk about a basis, we have to talk about spaces first. And so a space, I guess the common ones that I've seen, and there's probably others, but the ones I'm used to are just the space of all real numbers. And then, but you can also have like many dimensions of real numbers. So you can have R, that's just a number line. You can have R2, which is your X and Y axes. You can have R3, that's like your XYZ, and so on and so forth. You know Rn. Okay, good. So a basis is something that spans R2. Yeah, like complex numbers are a special kind of R2. They're not exactly R2, but yeah, I remember your Ishan. And so if you want to have a basis, so you can make a basis for R2. And what that means is X and Y. A basis for R2 means that you need enough vectors such that you can take every linear combination of them and get anywhere you want within the R2 plane. So if I have the vector 1, 2, I can take linear combinations of this vector. Now, and this is getting into the addition and scalar multiplication thing that you asked about second. It's similar to it's the operation under which you want things to be closed. Okay, so maybe that's actually a helpful thing to talk about now. Combination given a set of vectors, linear combinations are scalar multiples of those vectors added together. So if the set of vectors that we're given is, I'll just do two two-dimensional vectors just to keep things small. 1, 2, and minus 1, 0. One linear combination of these vectors could be, say, 2 times 1, 2 plus 5 times minus 1, 0. And we could do the scalar multiplication with each of these. So 2, 4, minus 5, 0. And then we can add these vectors. So we just add the corresponding components. So the top adds to the top, the bottom adds to the bottom. So we get minus 3, 4. So minus 3, 4 is one linear combination of these two vectors. And we can talk about every linear combination by making these arbitrary constants. Instead of 2 and 5, we can talk about like an A and a B. You know, make transition? Okay, perfect, perfect. So when we talk about a basis for a space, we're interested in a set of vectors a set of vectors that spans the space and are linearly independent. This capitalization thing is so there's two conditions here. What if we multiply it with another vector and add it? Multiply what with another vector? So A, B, C, and D are 4 vectors, sure. Well, not no. A linear combination. So yeah, don't just pointing out another issue, but even more fundamentally, a linear combination is only scalar multiples. Like the only multiplication you're allowed to do is with scalars onto an element of the set. You can't multiply elements of the set with each other. Otherwise, it's some other combination. It's not a linear combination. And so yeah, if you wanted to apply two vectors, you do need to make sure it's like a row and a column. But trying to interpret like a set of vectors like this, I have no freaking clue what this would mean. Like I there probably is some like context where this is meaningful, but like I have no clue what you would do with a set like this. And you would still have things that you wouldn't be able to multiply together in that case. You can't ever talk about spaces of matrices, and all of those products would be defined, but that still isn't a linear combination. So, yeah, so if you want a basis for a space, then the vectors need to span the space, which we'll talk about in a second, and they need to be linearly independent. Those are the two conditions to be a basis. So in order to span the space, it means that you should be able to take linear combinations of the vectors in that set and get anywhere inside that space you want. So if in my example that I originally have, where I just have the vector 1, 2, this is not a basis for R2, because if I take linear combinations, I only get to do scalar multiples, and I basically just get this line. And this line certainly is not the entire R2 plane. So we need to add in a second vector. You got the definition? Okay. So I guess I'll go with the other example of -1, 0. Hey, Yanis. Yeah. Levy is asking about what a Hamel basis is, which I've never heard of. But before that, he wants to hear about what a basis is in general. So I can answer the question of what a basis is in general. The Hamel basis, I'm not quite sure of yet, but that's where this is like building towards. And so, or when you say you got the definition, do you know what it means to span, and do you know what it means to be linearly independent, or do you want me to explain those? Just the usual basis? Oh, okay. Like the usual basis like 1, 0, and 0, 1. I mean, so hearing those is like the canonical basis or standard basis or something. But that might be another word for that. The usual definition of basis. Oh, interesting. It's a definition, not a specific type. Okay. Okay, so or intuitive, I think linearly independent means you can reach that vector. Oh yeah, you can't. Perfect. That's the perfect thing. So yeah, if your set of vectors is 1, 2, and 2, 4, these are dependent, like not independent, because 2 times that one is equal to that one. And same, and it's a little bit harder to check with 3 vectors, but like you'd have to check that just why not? Like if you have 3 vectors, you now have to check that like you can't add any multiples of these 2 vectors to make the third one or something like that. Hey, Draft Fusion, good afternoon to you too. And so yeah, what you said right there in chat is perfect. As it turns out, you can prove that if you want to make a basis for R2, you need exactly 2 vectors. If you add a third one into this, it will always be dependent and therefore no longer be a basis. If you want to make a basis for R3, you need exactly 3, R4 exactly 4, and so on, like that. And that's because you only need 2 vectors to span it. So if you add, you only need 2 vectors to span R2. So if you add a third one, span is another word for linear combinations. So that third one is always going to be some linear combination somewhere. So that's what a basis is in general. It's kind of like a minimal set of vectors that give you the entire space is how I think of it. Like there's no extra fluff or anything. I was looking at this stack exchange thread for the Hamel basis part specifically. This stack exchange thread is saying there's kind of conflicting definitions for Hamel basis. Spring saying the math rule definition is too specific. At a purely formal level, a Hamel basis is synonymous with basis. Interesting. So based off what Yanis said in the stack exchange thread is saying, I think Hamel basis is the exact thing that I've just described. Mathematicians tack on the word Hamel because I guess in certain contexts you have other types of bases in other types of math. And it sounds like the Hamel basis specifically refers to this linear algebra idea of what a basis is. And maybe there's like a topology idea of what a basis is, or some other branch of math has its own idea, and we need to distinguish between those. That's what it seems like. It's nice to know that you're working in some other field than the reals. Oh, okay, yeah. It Hamel basis, like, I mean, our basis isn't specific to the reals either, though, right? I don't know. I know. I've been thinking of Mark Hamill. We endow V with a topology. Very flowery wording. It's probably an actual like math term, but it's also an arbitrary vector spaces. Of course, only finite linear combinations are defined, so there's no notion of convergence. Functional analysis, you often want to allow infinite linear combinations. So then basis just doesn't mean basis anymore. Everything becomes weird to phrase. Okay. Yeah, and so that's where my knowledge like falls short. But it sounds like it's a helpful thing for more advanced types of math where the terminology starts to conflict with each other. You need to make new terms that don't conflict. Yeah, Levy, I hope that helps. I guess let me know if you have anything else you want to ask about it. Red alert. A handout by Evan Chen called Monsters? Uh, I don't know what that means, to be honest. To this? Hamel basis. Oh, you're doing this type of stuff. R has a basis as a vector space of rational numbers? Really? So there's just an infinite collection of real numbers. Oh, you were staring into the abyss. That's true, Dojo. I guess it has to be infinite to get irrational numbers. That's the part that I'm weirded out by. Um, but if I ignore that piece, Levy, I think what's happening here is that these E sub alphas are your one-dimensional vectors, and the A sub ones are the scalar multiples. But in this case, a one-dimensional vector is basically just a scalar. So it's a little bit weird where you don't. This is like it's a basis for R1, which means that the vectors aren't very vectory. They're just kind of regular numbers. Um, the unique piece is kind of interesting. Oh, the real number. Oh yeah, E alpha are real numbers, while A's are in Q. Wait, which one are the numbers? Oh, okay. Hey, Jaden, I'm good. How about you? That makes sense. Okay, so E alpha is any real number, or not necessarily any. Well, it's an infinite amount of real numbers. I don't know if we know exactly which ones or if it's all of them, but doing well. It's good to hear. And you can multiply those real numbers by a vector of rational numbers to make any real number. Yeah, sure, Jaden. I think we're coming to the end of this current question here. Can I explain it line by line? Let's try to do that, yeah. Okay. Yeah, the I do find this phrase a little confusingly. Um, so I guess the first sentence is that oh, this is the song, but Fembox isn't here. That's a tragedy. Anyway, uh, this means that there is some set of real numbers that act as our vectors. Um, 0, pi, minus 1.1, whatever. We could multiply, and if we multiply these sort of like vectors that are one dimensional by a vector, or we can take linear combinations of these real numbers for whatever reason, specifically using rational numbers, and that still is good enough to form a basis for R. Um, I think that's what's going on with the first sentence. Oh God, Jaden, you have one of those. Okay. Um. You'll be next on deck. Okay, so sentence two is most of the definition. There exists an infinite collection of real numbers. So the second sentence is saying that this set S, um, if we let it be infinite, which is apparently okay, um, can give a unique way of writing any real number with in a finite. That's funny. Any real number x as a finite linear combination with rational numbers, number scalars. In a unique way, which is kind of interesting to me. Yeah, I believe those A's are like, yeah, like these things are rationals. And the E sub alphas are just real. And the E alphas are basically the vectors in S that are forming this basis. Oh, not two again. So I've never like this is kind of a application of a basis, I guess. Um, but I think that's what's happening with this proposition here. I'm doing good, Hembox. Thanks for asking. I was just because I was back to working on that one hemispherical shell center mass one. Um, and then I was planning to go to linear algebra. But Levy happened to ask this linear algebra question anyway, so repeat what a basis is. Yes, so a basis is a set of vectors that spans the space and is linearly independent. So in the context that we're talking about here, um, we just have individual numbers. So they can't be scalar multiples of each other, or at least, yeah. They can't be scalar multiples of each other with rational numbers. I think you do have to require that. Um, Otherwise, things get weird. Um, linearly independent of what? What vectors can't be used to reach those vectors? Okay, so if I try to make like they have to be linearly independent of each other. So just like within the set. So if I try to make my set S um pi root 2, these two are fine. There's no rational numbers we can multiply to go from one to the other. But if I start to include like 1 and 2, these two numbers are not independent. And yeah, Yannis pointing out a problem with dojo drummer's basis. These are dependent because you can just multiply 1 by 2 or 2 by a half. So I think as soon as we have any rational number, we've covered every single rational number. Because we can take any scalar multiple of 1 and get to every rational number, right? So it looks like the set S is mostly irrational numbers. It might even have to be like every irrational number or something. Maybe not every, but... Hey, Joel. You got? Okay, awesome. I do want to get to Jaden's question now. But if you want to talk more about this, or if you have a separate question, we can put you back in line if you want. Now, unfortunately, we're about to switch gears into trig and bearings. But that's the way that the cookie crumbles. Okay, so what's happening here? Two ships leave port at the same time, one ship sail in the direction of north. The basis for R over Q has to be uncountable. That makes sense. Yeah, it's when I actually tried to describe a set S, like it seems like you just need every irrational number, unless I'm missing something. One ship sailing, that's all the teacher gave? That's probably all we need. One ship sailing in the direction of north, 23 degrees east at a speed of 11 miles per hour. Second ship sailing... Ugh, it's terrible. Set up a compass. E and 2E, for example, are irrational. Oh, okay, yeah, I meant every kind of... Yeah, that's a good distinction. In my head, I meant like just put in E once, and 2E is basically E. But yeah, you're right. I did misspeak there. Yeah, I was imagining like independent irrational numbers, I guess. Ugh, I never said that before. I don't think. Okay, and so both the ships are saying they leave from the same port, so make that port the origin. The first ship goes 11 miles per hour for an hour at north 23 east. So I'll just call it like that distance there. And we know that angle here is 23 degrees. I'll see Murdo, thank you. The other ship is going at 15 miles per hour, going southeast. So since they're going faster, then I'll make their line a bit longer. That angle is 67 degrees. Oh God, Joel. Wait, do you have to actually solve that differential equation or just find where it's a constant? Those are very different tasks. Solving the differential equation looks probably impossible. Or it's not possible with the way that I can think of. I'll put it on the screen, and we can think about it more after this one. But you mean solve? Oh well, happy birthday, Rob. Um, actually, okay. If someone wants to start thinking about this, feel free. But I want to rewrite it without the weird YouTube formatting. Is this your equation here, Joel? Because it's hard to tell what's like inside the fraction or not when you don't get to like write things by hand. Um, okay, so we have 23. If they're going for an hour. Hey Dora. Nice. That's awesome. Getting distracted is the best part of streaming. I'm glad to hear that. And if anyone wants to talk about space stuff, go hang out with Dora. 11. Okay. So Joel, please confirm if I interpreted that correctly. I'll still have to think about this after I work on Jaden's quote question, but I want to make sure that I wrote down the problem right. Um, the denominator divides everything. Okay, good. Thank you for telling me that. Yeah, that's good enough. Okay, so that's the differential equation that Joel's asking about. I'm not immediately sure how to solve it, but we're gonna think about it after Jaden's. One and all the set of equivalence classes over Q of all irrational numbers. You have to remove the finite sums too. We need to axiom of choice situation. Oh, I guess like E plus pi. Huh. Yeah, that's kind of funny. Like, what if E plus pi is accidentally equal to like root 3 or whatever? Like that type of situation. And root 3 is just a random number. I know it wouldn't be root 3 exactly. um okay, so the bearing from the second ship to the first. So the second ship is this one right here. And so I believe the bearing from the second ship to the first means that from the second ship's point of view, this is north. And what's the angle from north that goes for, like between north and the first ship? I think the angle we're after is that one right there. Um, one, two, north. Okay, that's how I'm interpreting the problem here. Uh, What's the easiest way to do this? Is there even an easy way to do this? We could use law of cosines to get the length of this triangle, or the length of that side of the triangle there. We know we're forming a right triangle over here, but we need to know an angle or a side length in that triangle. Like another one. Don't forget about the curvature of the Earth. True, Dora. Okay. Well, I'm not going to think about that quite yet. Let's start by getting the length of the distance between the two ships, and we can do that with law of cosines. So I'm going to come over here, and just distill it down to the to that triangle there, basically. This is side length 11, the distance the first ship traveled. This length is 15, the distance the second ship traveled. This angle here is equal to 180 minus those two angles, right? Because they're supplemental. 23 plus 67 is 90, right? Ooh. Interesting. That's a right triangle. Okay. And so the hypotenuse of the right triangle is this, with the Pythagorean theorem, is square root 15 squared plus 11 squared, which is root 225 plus 121, which is root. Usually you're allowed to calculator for this, so if you just want to take that and plug it into a calculator, then go ahead. But 3, 4, 6. No way, that's a perfect square, right? That I'm going to let Wolfram Alpha simplify for me. That is extremely pedantic, Dojo. You're right. Ooh. 346 has no perfect squares in its factorization. It just kind of is. It's 2 times 173. Huh. Okay. So we're just leave that as root 346. It's also 18 point something, which you could call it that. I like to leave it as root 346 though. Use cosine, sine, tan. Oh, okay. Well, I think Pythagorean theorem is just better, but no, this is just better. We don't know what either of these angles are yet. How can we? But if you have to do it like that, I want to do that. We just need to. Uh. We just need to work out what one of these angles are. Yeah, me neither. Um. Pythagoras Giga Chad. Yeah. Okay, so if you really want to do it with trig, What you would do is, let's say I want to figure out what this angle here is. You could also figure out the one up top, but just to choose one. I'm going to call this angle, I guess, A. You would say that tangent of A, because we know 11 and 15. 11 is opposite, 15 is is adjacent, and tangent is opposite over adjacent. So tangent of A is 11 over 15. So then you take the inverse tan of each side. And that should give you the same result. I'm sorry, no, that should give you the result of the angle. And so let me do that quick. Uh, 36.25 degrees. And now that you know what this angle is, we can use sine or cosine to figure out the hypotenuse. We can say that, let's just say sine of 36.25 is opposite 11 over hypotenuse, that I'll abbreviate as HYP. So the hypotenuse, if we rearrange this, is 11 over sine of that. And that should give us 18 point something. It sure does. So that's the trig way if you have to do it the trig way. I don't like it because there's two like steps in that, but it's equally as valid. My hardest math class, the one I had the hardest time with was probably discrete math. Let me shove this down. I need some more room. So 18.6 something. So thanks that you just left. Okay. You'll be back. You gotta go. Okay, I'll keep working on this problem. Feel free to check the recording. Okay, so now what? I mean, yeah, basically. Now what we want, because we're ultimately after that green angle there, so we can think about this right triangle here, I guess. And we can figure out what each of the legs of this right triangle are. We only need one though, because we already know that hypotenuse is 18.6, or that weird square root. So once we get one of the other sides, we're set. We can solve the entire triangle. And so I'm gonna go after this leg here, because I know that this leg, it should be the horizontal distance of ship 2 minus the horizontal distance of ship 1. And you could go for the other leg of the right triangle by doing the vertical distance of one, I guess, plus the vertical distance of the other. Like I'm doing this very like graphically here. Or like, you know, like just like visually, I guess. So if we want to figure out the horizontal distance that ship 2 has traveled, let me come down here and draw a little figure of kind of the distilled problem that we're working with here. Ship 2 is right here. This angle is 67 degrees. This angle in here is 90 minus 67. is 23. And we know the hypotenuse of, that's a right triangle. We know the hypotenuse of this is 15. So if we want the upper part, like the horizontal distance, the horizontal leg of this right triangle, we want to take cosine of that 23-degree angle. Because we want the adjacent side of that 23-degree angle. So cosine of 23 is equal to adjacent over the hypotenuse of 15. So adjacent is equal to 15 cosine 23 degrees, which is a job for a calculator. $13.8. Okay. And so now let's do the same thing with the first ship up there. We're after this horizontal distance up here. We know that angle is 23. We know the hypotenuse is 11. That's a right angle. So this time we want opposite of 23. So let's take the sine is equal to opposite over hypotenuse of 11. So opposite is 11 sine 23. It's another job for a calculator. $4.3. Wait. Yes. Make sure that I was in degrees and not radians. Okay. So now I'll draw the green triangle down here in green. We worked out the hypotenuse as root 346 because I like using weird numbers. That's a right angle. We want this angle here. And we've just worked out that this side up here is 13.8 minus 4.3. Mental math, don't fail me. 9.5. Yeah. So the last piece of the puzzle here is we want to solve for an angle. We know the opposite and we know the hypotenuse, so let's take sine. I'm going to call this angle B. Why not? It can be anything. Sine of B is opposite 9.5 over the hypotenuse root 346. 9.5. And then take the inverse sine of each side. .5 over square root 346. 30.71. All right, all right, all right. Well, that's not approximate. That's equal. Tyler, using the Coriolis effect of the Pythagorean theorem. Perfect. Okay, so this is basically the problem is done now. We just need to make it a bearing. So the bearing is going to be north. The angle we just found, west, because ship 1 is west of ship 2. So the bearing is north 30.71 degrees west. And I'd say that's the answer there. Okay, so Shaden had to leave, so I won't be able to hear a question if he does have one, but because of that, I'm just going to start working on Joel's question here. with this terrible looking differential equation. Apparently we need to solve this somehow. It's not linear. Okay, this is the other song. The song just played earlier. Okay, how hard can we try to separate this? Like, cross multiply and check whether it's exact. Ooh, that's a thought too. Um, I forgot about exact diffy Qs. How does exactness work again? I need to look at Paul. Paul, where are you, Paul? I need you. You did it that way. Problem is it doesn't match the answer. Okay, let's see if we can do it. We need to get them on the same side. And we need the partial. Yeah, this is the thing. You check it by reversing your partial derivatives. Like the thing with x, you take the partial of y. So we want the partial with y for that thing. We're going to call it m, just to match Paul's notation. We'll call that n. And so m sub y, my, is 2xy, n sub x is 2xy. That works out. Okay, perfect. Thank you for telling me that that is exact. And so once you know this, that's right. You integrate m with respect to x or n with respect to y. It's been a minute since I've solved this, so I'm looking through the example right now to compare. Okay, so then you set phi sub x equal to that, or psi, sorry, psi sub y equal to that. And so then psi should be equal, you want to do m with respect to x? Okay. Xy squared minus cosine x sine x dx. Okay, integrating this. That first one, we pretend y is a constant, so it'll be a half x squared y squared. This one we need to do a u sub on. Algebraic topology? I'm sorry, I know nothing about it. Maybe someone in chat does, but I haven't studied that in my life. I'm sorry, Cold. Plus some constant function, or plus some function of y. weird integrals? It depends how weird you're getting. I only know the integrals that you would see in like a calc in like a calculus class or a differential equations class, I guess. Um, Integration be a problem for my college. Oh God, uh I probably can't do it. I can look at it, but those are definitely not my strong suit. Um, okay, so then we have to we figure out this. Oh yeah, we take the partial. Okay, yeah, and so to figure out what our kind of function of integration is, we take the partial that with respect to y. That's how this works, right? X squared y. That goes away. Plus h prime I. And we set it equal to n. No, n is that. X squared y minus y. Yeah. So the x squared is y cancel, and we get that h prime of y is equal to minus y. So then we integrate to find that h of y is minus a half y squared plus c. Okay, so then psi is a half x squared y squared minus a half sine squared x minus a half y squared plus c. And that's just our answer there, I think. Okay, I'm glad that one is exact. That makes it way less scary. We can check our answer in Wolfram just to be sure, but I think we did everything right. Whoa, that's freaky. How does Wolfram know the exact differential equation I'm going to ask about? Are, am I being watched? Is someone at Wolfram Alpha like watching the stream right now? Okay, like I guess I'll take its generosity. Uh, if you're in my Discord, I mean, you can type it out there in chat if it's possible, but if not, you can post it in my Discord, or even if you put in like the elements or something, I can go and pull it. What is this? To be honest, I think Penn Center would probably be the best bet for an integration B question, but I'll still like at least look at it. Why does that look so much different from my answer? Did xy squared minus cosine x sine x or y 1 minus x squared? That seems like Wolfram got the problem down right. I could solve it for y. Oh. You're right, I found psi. How do you do that? Oh, you assume psi is equal to a constant? Is that it? Okay, yeah. Okay. Yeah, I forgot that's a step that you do in this. Um, we solved it for yeah. It's not exactly the thing that they're asking for. I think in my class we learned setting equal to 0. It doesn't. It shouldn't matter. Like you could call it another constant and then combine it with the constant we got before, and it doesn't matter. So I'm just gonna um I'm just gonna set this equal to 0 because it's really not too important, and try to solve this for y. So we can factor y squared out from these two terms. So y squared. Why are there cosines in here? Or in both Finlock's solution and the Wolfram's solution. So I just got a sine. Maybe it's probably equivalent. I just did the other u sub. A half sine squared x. I'll just make it plus c even though it's minus c. Half x squared minus a half, and I could cancel the halves. Yeah, this is equivalent to cosine squared plus c with Pythagorean identity, right? Okay, I think uh it's y squared equals that is the answer, or you could say y equals plus or minus the root of that. And there are different forms for this answer that are equivalent. And that comes from you can say that sine squared is equal to 1 minus cosine squared. And you could, but the plus c is up in the numerator too. So you could like combine the 1 with the c and it just looks like a cosine. I think that's why this is equivalent. And so Wolfram did get the other version with a minus cosine squared. But yeah, I think that's how you do that. So let me know if you have any questions, Joel. Oh wow, that is a crazy looking integral. Yeah, I'll try to draw that on the journal plus plus in a second. I assume that Cold's being careful with the parentheses. Oh, it is in the denominator. Oh, okay. Yeah, I mean, if you have LaTeX like copy pasted, and it's easy for you, I can render it quick, but if this is right, what I've written on screen, I think it's okay. So I don't know if it's a good thing or a bad thing, but these two arguments of the ln aren't exactly the same. One is a minus, one is a plus. This is it? Okay. Those two logs are reciprocals, Fenbox says. A radical and a 2. Yeah. So I guess just to put it out there, we know this can be split up with log properties. I kind of want to investigate what happens if you bring the 2 in as a power. Oh, it's 1 plus sine squared. Oh, that's so lame. I thought it'd be 1 minus sine squared, and we get a Pythagorean identity. Hmm. There is the half angle formulas that could give us something. The 1 plus cosine 2x being over here does kind of make me start to lean towards thinking about double angles and half angles. Let's see what happens with what's inside the ln with the half angle. I'm wondering what happens if we group the 1/2. Oh, that's not a thing. No, 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 no. That's all wrong. How did I manage to get another phone call? My phone never rang. Why is my phone doing this? I'm gonna have to figure out what setting is turned on that shouldn't be. Okay. Well, I'm not sure what to do with that. With any of that log stuff. Is 1 plus cosine 2x... Oh, that's an interesting observation, Liberd. Can half angle the ln. Oh, like the ln on the bottom here? Um, that is indeed the integral of secant. The top ln you can do that with, you're saying, cool. Okay. You half angle. I guess if you bring the squared in, is where you're going with that. Really? I didn't say like it was going anywhere when I was doing it. Um, if we can, I can just believe you though, without showing it for myself. Or we can make Wolfram play with it too. Oh, you did that identity. Hmm. Oh wow, that's crazy. Is that actually tangent though? These aren't the same. Unless I'm misinterpreting you still. It is a minus ln, so we could flip it. But that doesn't help. Oh, you don't want the squares? Just because there's a 2 outside. Oh, okay, then that checks out. Sorry. I assumed that the squares were important. Um, this thing to get inside an integral, and the fact that it's a definite integral, like, I think, isn't King's property a thing? or like it might be relevant there. I never actually use it for myself though. You like Lubert's idea more though? Okay. Going at it from this angle. So it that's the integral of secant, this thing. And so I assume that means we want to do a U sub, and or maybe saying the integration by parts. No, integration by parts. No, not integration by parts. uh, oh wait, I'm pretty sure it's the integral of secant, not tangent. We should verify though. I just realized that Lubert said tangent. Secant is ln secant plus tangent. Okay. So I'm still not sure. Like, would we take u equal to that? I'm not sure what that would do for us. Hmm. Derivative of ln secant x plus tangent x is secant x. Well, yeah, isn't that what Lubert said? Like, if you take the derivative of that, you just get secant. Or I mean, Lubert actually said tangent, but I think that was the idea. Um. Okay, just so we can see how it looks. Like, I'm just kind of messing with things. Like, what if we deal with the cosine 2x? Um. So I'm not entirely sure what to do. Oh, I was just thinking about it. I think I said I was going to pronounce your name as like Joshi. Thank you for the follow. Uh, I'm not a fan of that choice of words, quintuple A, but this is pretty mean integral. It's from an integration bee for from Cold Gold's university, I believe. Head home in search of dinner. All right. See you soon, Pinbox. This gives us a secant. The thing is, it doesn't give us much else. Yeah, it definitely is not easy. Um, ln divided by ln isn't anything. It's kind of annoying. Oh my. Hey, Papadoria. um, you stumbled into an integration bee type question. So someone finally asked a harder question than you. Well, not necessarily. You did ask me the Colette's conjecture, but this is the original problem here. It's a competition integral though, so it's specifically very difficult. Yeah, exactly. So we're just kind of playing around with it. So like Cole Wilpers asked the question. Notice this fact here. Lubird noticed this here, and I haven't noticed anything useful. I just want to maybe I should plug in the arguments for these LNs and just see what Wolfram Alpha comes up with. Okay, the squared version, what does it say? Nothing that immediately tickles my fancy. Now that's interesting. Well, what is King's property? Because I'm just seeing the pi over 4 coming up again. And I know that King's property exists, and it has something to do with symmetry and definite integrals. Really? I said property? Oh, wait, yeah, okay. Of course, it brings up, like, real estate places. Oops, not that. Ah. Hey, Storm. Um, the problem is this one right here. It's from Cold Golden Chat. It's an integration B question, so it's supposed to be very difficult. Oh god, it's stretchy. Sorry. I'll leave it up for a little bit here, but if, you should take a screenshot of it or something if you want to copy for yourself. So I'm about to put the page back down and look at the what I was looking at before. Hey, Suhaib. Ooh, wow, that's very simple. That's very like simple answer for a complicated problem. Okay, so spoiler alert. The answer is the square root ln 1 plus root 2. Oh, Papadoria. Post anything on the king's rule, king's property, whatever. Because I'm just seeing how Pyrophore, you can keep writing this for like the trig parts with Pyrophore involved in them, and that just seems like potentially helpful, or like this might be potentially be helpful. If I so bad, oh, I'm sorry. So I guess here they're doing the reverse of what I was thinking, where you have a simpler integral, you make it more complicated for a second. As they're taking advantage of co-function identities there. Hmm. And so what was the other one? This one can be written like that. You have division. You first remove secant x tangent x. Derivative of secant. Wait, if I do what division? Like if I split it up into two fractions? Sine over cosine squared is secant x. Oh, okay. Yeah, so I looking only like that piece of the fraction. Yeah, I guess let's at least think about that. Because my thing with King's property, I have no clue if I'm actually saying anything remotely helpful. So Lubert is saying, um, this is potentially integration by partsible. Let's at least see what that would give us. So the thing we'd have to take the derivative of, I guess, is 1 over that, which is a little unfortunate. The thing we're integrating is secant x tan x. Derivative of this. It's minus a half. Ooh, this is gonna get ugly when we have to integrate later. So that's what it seems like, at least. Oh wait, that we said is secant if we take the derivative. So I'm going to multiply by secant for the chain rule. Okay, so uv is secant x over... I'm just going to copy that. I'm tired of writing that denominator a million times. It'll be minus, but that's a minus there, so I'll do plus. Okay, so that seems to be the result if you do integration by parts there. um, yeah, and so that seems difficult to integrate if possible. So I'll take this work and I'll shove it somewhere else for now. Oh, you missed a secant on top? Okay. Yeah, I mean, I was thinking that maybe there could be some U sub with the inside, but I wasn't quite seeing it. Um, yeah, if it was just a oops, sorry about that. If it was just a secant, that would definitely be partsible, wouldn't it? Okay. Um, so if I instead observe that ln 1 plus sine x over cosine x is ln proof by Wolfram alpha, um, sine pi over 4 minus x over 2 cosecant nope, x over 2 plus pi over 4. Um, allegedly, King's property would tell us. Well, let me plug that in first. I don't know what to do with this sign on the outside. Or the cosine squared on the bottom. Oh, does the cosecant just not follow it? No, we can treat it as minus negative x over. Wait. I was assuming that we could just make that work when we get a minus sign. Is that allowed? Is cosecant even or odd? Even. No, odd. Um, I don't think King's property applies to that. Um, I was trying to go from the right to the left. Should I be trying to go from the other way, though? Maybe we should. U equals 1 plus sine x over cosine x. Territar wants to try. No, we haven't tried that specifically. You might get some nice cancellations. And Storm was pointing out the derivative of the square root of that. Really? Okay. Okay, instead of doing my king's property thing, then let's just... I'm kind of losing faith in it. That it's just... The pi over 4 is showing up so much in these alternative things that I feel like it might come up somewhere here, but... I think Territar's U-sub is easier to quickly investigate, so let me try looking at Territar's suggested U-sub, and then I'll look at Storm's. Territar wants to look at 1 plus sine x cosine x. And what is that? Secant plus tan. Du is secant x tan x plus secant squared. Do you get cancellations? Oh, ln of that. I thought I was looking at that before. Or we still can't deal with that thing is the issue that I ran into with that Territar. Put u equals pi over 2 minus 2x. Okay. Let me look at what Storm is saying. Derivative of the square root ln 1 minus sine x over cosine x. What is that derivative? Use Wolfram? What, you don't want to do it painfully by hand, Storm? Good. It's a good idea. You're in your bed, so you're doing it all in your head? Yeah. Give me a less disgusting form, Wolfram, please. These are more disgusting. Yeah, I'm not sure what cancellations that would give us, but mentally at least. Ooh, is that a fact, Territar? I didn't know that. Territar is pointing out that ln secant x minus tan x is equal to minus ln secant x plus tan x. I did not know that. Oh, maybe you can get that from like flipping each side. Or from yeah, from taking the reciprocal. Um okay, let me I'm also curious about the substorm just suggested here. I think it's worth figuring out what our bounds should be. Um okay. And we do have a minus a half out front. So I'm gonna flip the bounds and make the 1/2 positive. So you're trying to follow early set of circles, they're actually negatives. Oh, okay. Um, why can't I do this math in my head? I guess pi over 4. Flip it. Aha. Maybe, I don't know. Oh no! Thank you for saying that, Territar. Ah. Amateur hour on the stream. um, I'm trying the use of what Storm is saying here. Now, for these LNs, is it do we want to make them secant and tangent? Because like um we could say it's tangent just of you, the ln on top. Let's do that. I don't know if we but then our arguments aren't the same. Or like there's like a phase difference. Let's just do it. The derivative of ln of cosine is minus tan. Oh, interesting. That one, I said proof by Wolfram alpha. Oh, that's not quite you, though. That's not you. It's not you, and it's not me. Maybe I shouldn't do that. The cosecant just doesn't work with it. Hmm. Do I want the cosine 2x to be cosine squared? So that the phases are the same. Yeah, let's do that. My force and u's are not very distinct. Okay, that... Of all the integrals out there, this is one of them. King's property is, it's that. I just know that it's used a lot in competition integrals. And I just keep seeing that we have pi over 4 as a bound and showing up inside the integrand a lot. Tertar, that is the answer. Cold said that's what the answer is. Papadoria linked this page on King's property. Did you solve it, Tertar? Oh my god, Tertar, with the use of that you suggested before? All right, like that you sub. All right, if Tertar knows how to solve it, let's try to solve it with that, because I don't know where this, I don't know what you do with that. So it's gonna shove to the shadow realm with the integration by parts attempt. No, I need to update that. No, I don't need to update that. This is the integral secant. Okay, so I don't know if it's worth swapping, or I don't know if it's worth converting the bounds to be in terms of u, so I'm just going to drop them for now. I assume the cosine squared is better than the cosine 2x. Sine x, I don't know what to do with. So I'll just let that be. Minus 2. Now this is where we use that fact to make it plus 2u. Sure. And now one of these cosines cancels with one of those secants. Is that what happens? What do I do with this? Actually, maybe I'll solve the bounds. Find a triangle property with tangent and pi over 4. Oh, a trig pop. A trig property. Ugh. There probably is something like that. I just don't know what it is. Apparently, Terratar solved it with this U sub. I don't know where you go from here, though. Hmm. And Territar's not this ugh, I don't know. Oh my god, dude, we do a +1 -1. That's what you do. I think that cancels things. I think it cancels the things that we want to cancel. I really hope it does. Because sine x +1 over cosine x is e to the u. Well, that's not easy to integrate. Um, Maybe it doesn't cancel everything we want it to cancel. Yeah, Mavort. That's what I'm trying to deal with right now. I thought this +1 -1 trick would give us what we want. It might not be the dream though. Um, to be honest, I thought these would cancel entirely. Yeah, like we can't proceed until we get rid of the x's. So I'm hoping for some type of clever trick. Um, the I don't think the trick I thought is working here. Should the cosine be squared in the bottom? No, the cosine squared that we used to have, I canceled one of them with the secant from the u sub. The original problem is right here. And the answer is here. It's an integration B type of question, though, so it's supposed to be very difficult. And Territar said that they solved it and got this answer using the use of that I was trying, but they haven't said anything since, and I'm kind of stuck with it. So I don't know what to do with that. Yeah, if you have a copy of this problem, take a screenshot of it or something, because I'm going to be scrolling around and stuff. I filled up so far basically 2 pages with different attempts for this. Integration by parts. uh, X equals 2u and put everything into cosine squared and sine squared. um, yeah, unless Territar tells me what I'm doing wrong here, like I don't know what to do with this. So I'm gonna try out Storm's idea, I guess. Can I make Wolfram Alpha do this for me? That'd be great. Territar doesn't really troll with that. Sine 2x minus 2 ln. I'm hoping that Wolfram Alpha will do all these angle identities for me. This will be a cosine 4x. I forgot parentheses. That is very likely. Let me... uh, there's a parenthesis I forgot. Did I forget an ln? No? Why is it ignoring... Oh, I forgot that those parentheses too. Ugh. The parentheses in the ln? Oh, yeah. Yeah, okay. I forgot a few parentheses. Oh my god, dude. In both the ln's. uh... This is looking better. Okay. That's almost... No, come on, Wolfram. You can do it. Get rid of the two X's. Wolfram doesn't want to do it. Simplify. Oh, yeah, yeah. I think you do it like... You can do it, or I don't know. I don't think... It's not doing it. Uh... We could give it we could give it pieces, I guess. Like, what if I give it just what was inside the ln? It still doesn't want to do that? Wait, that seems important. Because... I was thinking it seems important because... This website was saying that... Eh... Never mind, it's not really the exact same. No me gusta. Yeah, I don't like this problem either. Um, I'm very close to throwing in the towel here. This is so annoyingly almost simplified, but not quite. um, the problem is from Cold Golden Chat. The solution is supposedly this that another person in the YouTube chat confirmed. Um, but apparently Cold Gold got this from his university's integration bee. So in theory, I would certainly hope that it's correct. Hey, Jiggle how do you read like my handwriting or like what do these symbols mean? Or I don't know. There's a few ways of. This page is a whole mess of math that cause we've been exploring a problem, um, and not making a ton of progress with it. It's my handwriting. Oh, years of practice. That's how I read that. What we can do is that. Oh, good. We can get the series and then just integrate the series, right? It's much easier. Does Lormouth actually integrate this? Uh, with it gets stupid integrals. That's what it gets. Some of those seem. I don't know if they're actually something, but the point of me doing this was this. Uh, I guess so, Dora. I'll at least look at it. Is that equal to the thing that? So Wolfram Alpha does it numerically. ln square root ln 1 plus square root 2. Okay, so that matches. I mean, there must be a way to get this answer for the integral. It seems to match, unless Cold got tricked. um, into doing an impossible problem. They just happened to find this representation for the answer, but I gotta believe it's a legitimate integral that is just very difficult. Try to prove it's transcendental. Oh my god. Oh hey, yeah. Well, Malthus says it is. Apparently, I just saw it now, Dora. What does ChatGPT say to do about this? That's an interesting way of proving the same thing that Territar and Fembox were talking about. But okay, what does it do next? It's the double angle. Sure. This looks good so far. T equals tangent x. It's opposite over adjacent. Yep. So those are right. That's okay. A Bioche substitution? Interesting. Okay. I've stopped checking each of these individual steps here, but what is ChatGPT saying to do with an integral like that? Two fractions seems like a reasonable response. Oh, you probably have a U sub. Well, it is well known. Oh, I mean, I guess, okay. Yeah. I don't know if I'd say well known, but yeah, ChatGPT, as far as I can tell, is crushing this problem. At this point, I'm just kind of, I'm not really verifying it mentally. I'm just kind of like reading it and taking it face. I just see like the techniques here, but it gets that. Well, I mean, that still doesn't seem easy. Recognize the antiderivative? Oh, it's a product rule. Yeah. Bruh. That's the indefinite integral. Are we going to have AI integration competitions? I feel like this is just going to be a thing. It does get the right final step, which that doesn't mean every step before it is correct. I've seen ChatGPT spit out the right final answer with incorrect steps in between. Oh yeah, yeah. That's a good idea, Storm. Let's take the derivative of this thing using Wolfram. Um. Oh wait, this isn't the actual anti-derivative. F you? Yeah, F me. Oh, well, we would need to unsub it. What was you? U is the ln thing. It's arcsinch. Okay, so 2 root arcsinch. Look at the answer for I. Cinch ln 1 plus root 2 is equal to 1. Uh, with this justification, apparently. What model of ChatGPT? Dora said this is O3. This isn't my prompt. Or like I didn't interact with ChatGPT in any way to do this besides going on the website. You know, O3 mini high apparently. Um, I'm gonna put it back into Wolfram. We just need to do we need to unsub this. I guess we can unsub that. So it's square root arcsinch x, cinch of arcsinch x, which I assume is just x. uh, x square root arcsinch x. All right. That's kind of hard to tell. Um, do you know if it's a Darwin solution or if it's included in, if the data set included the problem? To be honest, I don't I know very little about how AI actually works. Like if ChatGPT's data set did include the actual problem, would it know just to spit out the exact thing that it was given? Uh, the issue with verifying the answer is that ChatGPT never unsubs, and there's a few levels of substitution, right? Wait, ugh. We have U. Oh yeah, U was in terms of T, and T is in X. Ugh. Okay, so do, 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 do. U is arcsinch of T. So it's square root arcsinch T times cinch of arcsinch of U, which I'm going to simplify it to be just T. And now let's unsub the T. T is tangent X. It's hard to tell with the cinch, because our arcsinch is something with ln. Write the formula from say u equal t equal, it will give you the formula. Oh. Let me bring this tab. Reasoning methods. They at least make it look like they're actually thinking and reasoning while it's working until you subsets doing. Think that this is a goof sub and so on. Yeah. Ugh. Square root u since u. T equals x. Like, I want to make sure it knows what to do with this. Nope. Like, I don't know. I don't know how to work Wolfram Alpha for something like this. Where? Oh yeah, where is a good word to use. I think it's too beautiful to be true. Hey, this is the thing that I was telling it to derive before. Hey, Phobos. So, okay, if I take the derivative of this, and I set it equal to the original integrand, Wolfram Alpha is gonna quit. It's gonna tell me to stop it. Oh, it's trying to solve it. It's not always equal. Oh yeah, duh. I should just look at the last page. We only care about 0 to pi over 4. It only gives counterexamples. Pi over 4 is less than 1. These are all more than 1. We need Desmos. Tan square root arcsinch tan. Oh wait, no, that's the thing about the derivative. We want, God, I want to graph these in Desmos. Oh no, Desmos can do derivatives. Tan square root arcsinch tan. Tan square root arcsinch tan. F prime of x. And then we want to do the integrand. I really hope I can copy paste this and Desmos will clean it up for me. It sure isn't. Okay, this is worth typing, I think. No. Da da da. Damn. Chat GPT, I can't believe you would deceive me. No, I wonder where it made a mistake because I guess I did stop checking about a third of the way through. um, I mean, I'm not sure. Dora said this is O3 mini high. Snaz is saying just try O4. I mean, I don't like interacting with chat GPT for myself, but that's the extent that I can avoid it. Um, hmm, unlucky. Apparently, Penvox. The derivative of the result ChatGPT gets does not seem to match the integrand. Um, is there a second check we could do in case I'm doing it stupid? I mean, I guess no. If I were to check it, I could check it for like each stage of the substitutions it's doing. Tell GPT it's wrong. It needs to try again. Ugh. Did I miss it too? Oh, ooh, ooh. Oh no. Oh, Storm. It was me. I missed it too. Chat GPT. The rise of robots and decline of man. Yeah, Phobos. That's true. Chat GPT, JPay, it did free me from the toil of Cold Gold's competition at Integral, so that's true. Yeah, there are a few levels of substitutions happening here. I can't come up with a better solution though. Like, you wouldn't lie to me. I don't know. I assume Cold Gold isn't here anymore. Let me see. Is Cold Gold? I don't know. I don't remember what Cold Gold's Discord name is. Is it the same? Can I get this to him? No, I don't think Cold Cold's Discord name is the same as Twitch. I mean, that's not the only integral Hermalpha doesn't know how to do. It's pretty common that it can't do competition integrals as far as I know. Maybe I'll send Cold Cold a whisper. This is a solution. It seems. I haven't verified every last step, but all right. Well, GG's. Thanks to Dora for getting that. It is a diabolical one. I I think it's time to like cleanse my mind from this problem. I'll keep the tabs open for a few minutes in case someone like says something about it. Um, but barring that, we don't have anyone else who's asked a question, so we might go do linear algebra. Try to integrate tangent to the 1/17? Oh my god. 90-minute integral. Could have watched a movie. I would rather watch some nerd on the internet try to do this integral than some movies. Like Twilight. Alright, from the first 4 chapters, what do we want to look at? The integral of tangent to the 1/17? I don't know how you'd even start with that. Maybe integration by parts. No, you can't. You'd have to integrate. No. No, wait, never mind. Maybe integration by parts. I don't know. Oh, do U equal... Oh my god. Okay. Hmm. I mean, I could get into the eigenvalue stuff. He's eigen stuff. Yeah. Lots of eigen stuff. um, I don't know. Do a minesweeper? All right, thank you. Because I can't make up my mind. Look at what you make. Research. Quillen cobordism? Quillen cobordism. What does the University of Chicago have to say about this? Differentiable manifolds, vector bundles, embeddings. Oh my god, what the hell? Second link? Unoriented cobordism ring and the complex cobordism ring. That's what you're researching. Unoriented cobordism generalized cohomology theories. That is a weird... I feel like That's something like Shakespeare, right? Where it has like Shakespeare has the what's it called? Where like every other word is stressed. Iambic pentameter. And for some reason that like this phrase feels like it has like a beat to it or something is what I'm trying to get at. I have no clue what's happening here. You're getting started to make it understandable for the human being. Okay, I wouldn't need that. 37 or basically 38 seconds. It's not clear your research being so hard now. 6 or 7? Oh, okay. I'll bring it back up. This model. Okay. 6 or 7. Oh no. Are we using pi to mean something other than 3.14? And epsilon to mean something that's not a real number more than 0? USAMO problems? Oh, you took it, John Smith? I've looked at them before. They're insane. Yeah, I know that there's some disturbed areas of math where they take pi and make it mean other things. Hey, 750, you're bocce? Hell yeah. How close are you to completing your quest to watch it over and over again? Oh wait, oh there's F high asterisk and F low asterisk. That's great. If X is the homotopy type of a finite complex, then UQ of X is a finitely generated abelian group. Oh, prove the minesweeper. There we go. Euro P, because for me, pi is a projection obtained in a pullback. Yes. P e to x be the projective bundle of lines in E. Let script O of 1 be the canonical line bundle on PE. PE is physical education, and it's a lame class, okay? Whose fiber I is a subset of C is the linear functions on L, and let Kasai be script E of script O of 1? What the hell? This is math? Apparently I need more fiber in my diet. The more awful paragraph is in part 3. Part 3. Oh, this is a 28-page PDF right here. In case you ever want some light reading before you fall asleep, this might just be it. Did I miss part 3? Am I dumb? The answer to both is probably yes. Come on. Wait. Wait, that's part 2. I missed part 3 again. Here it is. G structure. Snaz, I do not understand this, no. Apparently Storm does. I am not that much of a math Chad. See G manifolds. You're saying to just search G structure? Oh, the text might not be recognized. Oh, I probably passed it. This is part 1, part 1. Okay. Search G bundle. Well, okay, here's a G bundle here. Oh, is it this paragraph? Okay. Suppose that VI is endowed with an equivariant complex structure so that 3.5 is a direct sum of complex G bundles. I don't think men can find the G bundle. Let H be a multiplicative equivariant cohomology theory for G spaces with Tom classes for complex G bundles, such as equivariant KG theory or the theory UG star of Tom Deek? Question mark? We have in mind the theory that X maps, or the theory X go to U star Q, that it's a little too faded to read, where Q is given a principal G bundle over a manifold B, and where the Geisen homomorphism F star HX to HY. All right, see ya, Dora. Thanks for hanging out. Associated to a proper G map with equivariant complex orientation is the Geisen homomorphism. Yeah. These are definitely words. I can tell you that much. I guess good luck with that, Storm. Whatever the hell this is. It's what you do every day. I don't know how. What does the solver analyze? I have no clue, Snaz, to be honest. I'll leave that up. Who cares? It's a part of math that is way beyond me. I feel like I should go back to orthogonality. Really, some black magic to commute the cobordism ring of a point. Okay. Orthogonality is probably the thing that I've done the least of in linear algebra. I think 1 point is looking at 17, so let's look at 17 and beyond. Suppose S only contains 2 vectors, not a subspace. Then S perpendicular. Ooh, okay. Yeah, let's think about 18. How many pages? Oh yeah, okay. This ended up basically taking up 2 pages. Gold's problem. I wanted to go back to the bearings problem after looking at That integral, oh my god. Okay. To give a better understanding of the geometrical structure, it can be used in string theory and physics, for example. Okay. So, okay, S is a set of two-dimensional vectors, not a space. But S perpendicular is a space. It's going to be a line. Um, S perpendicular is the null space of surely it's the two vectors and columns, right? I need to go bed. I just pasted enrichment materials instead of a Twitch clip into Twitch chat. uh, there's only one sentence. Dude, that it's always a thought in my head where like if I have a Twitch tab open on one monitor and I'm like typing important information in on my other monitor, what if I'm actually clicked into the box in Twitch chat and like I put my credit card number into a chat or something? Should try it? Yeah. S perpendicular. S perpendicular is the null space. Storm wants to transpose this matrix. That might be right. Yeah, I agree that it's an issue that this is only two-dimensional. It should exist in three dimensions. Um, which would mean that yeah, we should transpose things. This would give us um a two-dimensional result. That might be something where though that might just be something we're willing to live with though. Um, maybe that means or that's an indication that the null space is just a line. Um, so what's the rationale for why this is true? Because I think this is just the answer for A. Do I want a hint? Sure. Like I could just find this using the cross product, but I don't think the book has even talked about those yet. Oh, wait, I might have it. In order for it to be in the null space, it should dot to zero for each of these vectors. Yeah, that's it. And in order to make the dot product work, you need to do that column times that vector as a row, and that column times that vector as a row. Okay. And that's how you get your zeros. To be orthogonal to S, you need to be orthogonal to vector v1, v2, which is a plane in R3. Yeah, and so we could do it with cross product. This book has been talked. Actually, have they? I don't. If they have talked about cross product, I can't remember it. But they definitely talked about um, perpendicular or testing for things being perpendicular using the dot product. And so basically, we want to take vectors and dot them with both of these and make sure they're both zero at the same time. And this system accomplishes that. So yeah, that's why that's our answer for A. Edison, you have an interesting counting problem? Oh, hit me with it. Let me check the answer here. This is, what chapter is this? 4.1, 18. Nice. Yeah, so this doesn't like tell us what the vector is, Storm, but if the dot product is zero, they're perpendicular because cosine of 90 degrees is zero. So that's just like how this particular book has been talking about it, but I could have actually found the null space by doing that, like cross product there. Would that have given me the matrix A though? I don't know if it would have. You can just put it in math discussion if you want, Edison. Also, one-dimensional subspace a line in R3. Its orthogonal complement is the plane perpendicular to L. Then L complement complement is surely basically the same line. Yeah. Okay. 19 seems like a gimme. Suppose V is the whole space R4. Then V perpendicular contains only the zero vector. V complement complement is surely V. Or R4, I guess. Is this not a gimme? Is complement complement like surely just getting back to your original thing? Or is there something unintuitive happening here? I'm just gonna look at the answer key. No? The complement ice in these cases just kind of undoes itself. Maybe there's some weird case where it doesn't. Edison, once you put in math discussion, just give me a heads up in chat. Make sure I see it. What's up with 21? This is spanned by the vectors that those. Find two vectors that span S complement. Well, this is just taking what we did in 18 and actually solving for X. Which I feel like I know what to do. Yeah, no, let's do it. Just get some practice with it, because we're going to get some free variables, and that's always good to be good at dealing with. And we're going to set up the same exact thing that we did in number 18. Oh, and here we can't do the cross product. So we're in 40. Let's do some row operations on that. Subtracting off row 1. Then minus 2R2. 1, 0, 0. 6, right? 0, 1, 1, minus 1. Find the basis of R4. Oh, yeah, true. We're getting basis of R4 given to, like, starting vectors. Okay, we're gonna switch gears. We have a counting problem from Edison in the YouTube chat. How many triangles can you draw using the dots below as vertices? Oh, God. Okay, no, we should be able to find a pattern here. Okay, so this is neat. Okay, so 3 points make a triangle, of course. But they can't be collinear. So we need to eliminate. Okay. Oh wait, I should read each of the parts first. Find an expression for the answer, which is the sum of 3 terms involving binomial coefficients. Difference. Oh, you have to get the same answer in different ways. Okay. Let's start with the question on top here, though. Theoretically, we could just track this first point. How many total vertices do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if these weren't collinear, we could just say the first vertex has 11 choices for the first vertex and 10 choices for the next one. And then the next vertex would have, like, I think we'd end up getting a factorial times a factorial, I think, is the point. But we have to eliminate these cases. Because those don't make triangles. And so I think this is gonna, I'm kind of thinking of it as part B first, to be honest. Because it's essentially, we have 12 things that we can choose any 3 of, except we need to subtract off the bad ones. We have 7 bad ones. Flat triangle cry with you. So do we subtract off 7, choose 3? I guess those are the number of bad triangles. I think that's what we'd do for part B. For part A, three binomial coefficients. What are the three things? Choose one, then another, then another. You're saying like 12 choose one, plus 11 choose one, plus 10 choose one? It can't be this exactly, right? Because we're not eliminating the flat triangles, but something like that? I don't think it's this exactly, Edison. Um, but I think it's something like that. I need to erase what I have counting twice. I don't know. I don't know what that means, or I can't quite figure out how to adjust this to be true. It's kind of weird because like there's different cases. Like I could choose those three vertices there and be fine, and this formula like would hold for something like that if they were all like that. But if I chose this vertex down there, then now my choices are only these for the remaining ones. Oh, they do say there is a difference in phrasing here, where part A says terms involving binomial coefficients. So we could consider a product like what you're saying. Um, you're saying to think about 7 choose 2 times 5 choose 1. Is that accounting for the cases? So I don't remember what happens when you multiply two combinations. If we choose any one of the original points, we can choose any of the other 11. But then if we choose one up here, Doesn't the choosing take care of that for us, Storm? Or maybe not. I don't know. Okay, Edison's full idea. 7 choose 2 times 5 choose 1 plus 7 choose 1 times 5 choose 2 plus 7 choose 0 times 5 choose 3. Oh, so you can choose 2 of the 7 and 1 of the bottom. Sorry, I have that reversed. 2 of the 7 and 1 of the 5 from the top. Or 1 from the bottom, 2 from the top. I see. Yeah, I think I like that. Um, yeah, I think I agree with this, Edison. In Storm, I thought that the us using choose here fixes that. Like that would only matter if we're doing permutations. Flat triangles are triangles? Oh, I I think we're not supposed to have a flat triangle. And so at looking at part C, I think these two answers should be equivalent. Well, I mean just from parts A and B, they should be equal. So let's check that. 12, 3, 7, 3. 185. That's not right. Uh, nope. 245. Wolfram Alpha is still not interpreting you right. 185. Good, they match. Yeah, they don't want the flat triangle, Storm, I don't think. Okay. And so apparently there's a theorem here. Racist to flat triangles. Ugh. Isn't a triangle defined as 3 points that aren't collinear though? At least in the geometry that I'm used to, right? Like I guess for Euclidean geometry. Um, thank you, Le Chiffre. X points on the horizontal axis, Y points in the semicircle. I guess so. Let's try to translate these two things to be in terms of X and Y and set them equal to each other. So the answer from part A, we had 7 things on top, which is the horizontal axis. So X, choose 2. Y, choose 1. X, choose 1. Y, choose 2. Choose 0. Y, choose 3. Yeah, this does feel a little I don't know. Shouldn't there be a better generalization than this? What's my advice for you as a second year math student? Uh, I don't know. I think just um, pursue what you're interested in, because that's what's gonna keep you like in it through the hard parts. To the greatest extent you can, just try to focus on the things that you like really want to do, I guess. Yeah, this is kind of a neat problem, Fizzbuzz. Yeah, I mean, we could simplify those. I don't know, like, is there a huge benefit in doing that? I feel like combinatorial identities sometimes just have stuff like this. Prove a binomial identity using the combinatorial proof. Maybe we should simplify that. I don't know. What does it look like if we do simplify it? Hey, Akil, thanks for being here. Some pawn formula? Oh, like with chess? Maybe. I want to generalize like the threes and the ones and the twos and the zeros, but I they come from the triangle, and I don't think we can get rid of the triangle. Like we can't. At least I don't think they want us to generalize to like any number of polygon. So is this as general as we can get? This doesn't feel like that cool of an identity. It's true, but oh, we could. I mean, there is a certain if we add the x minus three over, it has a neat symmetry, I guess. Maybe that's what they want. Yeah, like I'm looking for something that kind of looks a little cooler. Um, and like my only idea for combinatorial proof is to like say in words the logic that we use to solve parts A and B, which I guess we could do. Hmm. Like it'd be cool if we read it as a summation of some kind. Look at Van der Monde identity. Apparently, I've seen this before. I don't remember it. Okay, yeah, that is a cooler looking identity. Okay, yeah, I think this is what we want to do. Um, so x plus y choose 3. We're finding here, I guess, is x choose 3, y choose 0, plus x choose 2, y choose 1. So I don't think we wanted to simplify that. Like, I'd erase that step. I think we're going to do it for any number. Or I assume that's the point of this problem, is to get it in this form. And then prove it for any bottom. What's the difference between third year math and final year math? Uh, Usually in your final year, you might be working on some type of project depending on your university, or you're usually like a lot more specialized by the time you get into your final year. It varies a lot by school though, so it's a little hard to say in general. Um, so are do they want us to prove this inductively? Because we kind of have done a base case. Oh, thank you, Zone. Is proof by induction a combinatorial proof? Or do they say this is a proof? I don't know. It's probably not a proof. It's definitely not a proof. Two different ways to count the same thing is a combinatoric proof. Okay. So we can kind of generalize what we did in part A and B for X and Y. It might just be for three, like you're saying, Storm. Edison, I might be being extra with this, but Like it's possible that's what Storm is saying, and we just stop at 3 and we don't do this full-on identity here. But it is kind of cool. Yeah, I assume that's what's like the fact that you can just have it as R means I guess we're doing it as any polygon. Presumably. That does make the combinatorial proof harder, does it not? uh maybe that I don't know how intense Edison is supposed to get with us. You're going to sleep, Storm? All right. Thank you for hanging out. Sleep well. Okay, the combinatorial proof is I'm trying to think through in my head if we did allow an arbitrary R. It gets a little tricky, right? No, I mean, no, it's basically the same. Okay, but I think let's try it. um, and R sides and is a big vibe. Thank you, caller. The number of ways to make an R-sided polygon can be found shape. Oh, is polygon bad? I guess we can say shape. Oh, you know what? I guess if we did get up to 4, are we allowing things like that? No, you consider that just like you consider it this, I guess. We're not worried about how they're connected, right? Yeah. So, Edison, I might be going overboard with this problem. They might just want you to keep things as 3. I don't really know, to be honest. I'm kind of interested to see if I can prove it for R. I don't know if that's what you're supposed to do, to be honest. That might be going too far. I was gonna write out what the pattern is, then trying to make well, yeah. It was X. You think we're good here? Oh, really? The book doesn't have an answer? Okay. If that's good enough, then. Uh, yeah, you could take this formula and just set R equal to 3 as well, if you want to not go crazy with it. I just kind of assume with this stream that people ask me the most insane version of questions possible, because that's what people tend to ask about. But if you're happy just with like that, then I'm willing to just drop it. It is cool that this identity over here exists though. And I guess if you want to say the combinatorial like proof part of it, I would just say the logic we use to answer parts A and B. Wow, it happened again, guys. The time suddenly became not long before Zach's class starts. Okay, combinatorial proof of the identity 2 plus 2 plus 2 equals 3 times 2. Oh my god. I find I don't know how you would do that. How am I gonna do this? Zach's class is gonna start in 25 minutes, basically. Let me just check. Check out one thing. Okay. I just quickly looked. I didn't see another math streamer is on right now. What I might do is we'll just work straight through until it's time for me to hop on the voice call. And I'm just gonna put up like I'm gonna raid into Zach, but I'm gonna have like 15 minutes where I'm just gonna have the stream be on BRB or something. So we'll keep going for another 20 minutes. Okay. That's the plan. I need to start getting. I actually do have some, but I actually don't need them because I think next week is the last week of class. So marathon stream, I guess so. BizBuzz, this is I have too many tabs open. I'm on page 215. Ugh. It's this book. The little bit that I've looked at it hasn't been my favorite to be honest. I'm just kind of trying to get the fundamentals of linear algebra down, and I want to move on to a more advanced book. But there's a couple of things in this book that I want to get better with, like orthogonality. I might want to look at like LU decomposition a bit more. Eigenvalues and eigenvectors. I've done that so many times that I feel like I have that down because I was doing them for system differential equations. Oh no. Sorry, the combinatorics was completely unrelated. That was from someone in the YouTube chat, Edison. This I have no clue where it's from. It's from whatever book Edison is using from. If you're interested, I can see. Edison, are you still here? What book is this from? I'll type to Edison as well. It's possible that he dipped because we didn't answer the question. Sorry, I misunderstood which one you're asking about. Oh, you got it? Okay. I just figured I'd type in case you like me had on mute or something. Okay. I guess. I was just gonna get the actual null space of this just for the practice. We have two free variables. We set one to one, the other one to zero. Figure out what each of the vectors are. Um. Ooh. Thank you, Edison. I'll copy that over to FizzBuzz. Oh yeah. Or you can look at the YouTube chat. There you go. Okay, if we let x3 be 1, x4 be 0, then x2 is -1. Isn't x1 anything here? I guess so, so we can just make it 0. Oh no, x1 has to be... No, it has to be 0. Yeah, okay. Omni chatter, let's start streaming to TikTok. Yeah, same. I have never and will never make a TikTok. X2 will be 1. The 6 should be a 5. You're right, Lubert. Thank you. Turns out I can't even do arithmetic. And that is just, that's a perfect timing. So I was just about to figure out what x1 should be. And now I know that it's -5. Noish. Find two vectors. Oh, so the two vectors that span as perpendicular are those two. This was 21. Oh wait, oh no, I forgot what page I was on. Was it 231? It sure wasn't. It's close enough though. Wait, no, it's not close enough. That's what I was doing. Okay. 4.121. That's what I got, right? Oh, I made an oopsie on this one. Oh wait, no, these are slightly different. Um, I have 1 0 rather than 0 1. I think that's... Is that okay? Yes, it is, because that's a... I can make those vectors with linear combinations of mine. Okay. So that was 21 that I just did. Let's look at the next set. Wait. An invertible n by n matrix The first column of A inverse is orthogonal to the space spanned by which rows of A? Let's think about that. Isn't it none? It's none with a bun. Because in order to be orthogonal, you would need a column of zeros. But this is the identity. There is no column of zeros. I think this is a trick question. Surely. $24. No, I'm just dumb. Column 1 of A. Ew. It's everything except the first row. Why is that? Column 1. Oh no, I was getting mixed up with null space. I see. Okay. Column 1 is orthogonal. Column 1 determines column 1 in that resulting matrix. And it dots to 0 with all of those entries. I see. Okay. No worries, Edison. Thank you for the question. Okay, never mind. It's specifically not orthogonal with the first row. Okay. Find A transpose A. This one looks interesting also. I'm getting identity matrix vibes. The shift rate, if you are gonna do it, then do it quick, so I'm gonna have to go soon. But you can type the question there in chat, or you can put it in my Discord. Okay, so these are perpendicular unit vectors. The magnitudes are 1, and so either the dot products are 1 or 0 if they're perpendicular. Could they all be 0? Could they all be mutually perpendicular? No, because it's A transpose A. I'm going to do it with an example. Nope, 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 no, 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 no. There we go. We get a 1 there. Wait, 2 by... This is a 2 by 2. That's fine. It'll just be really big 2 by 2. 0. 0. Okay, yeah. And so, oh yeah, there was something... I forget what it was, but there was some situation where A transposes A inverse. I guess this is evidently one of them. Or no, oh, it's a kind of inverse because A isn't a square. I guess it would be a left inverse. I think I haven't learned what left and right inverses are, but I assume that's what they are. Okay. Let's check the answer. That was 25. Okay. Well, that's annoying. I mean, it's a diagonal matrix for what we just did in 25. The only difference is now we're multiplying the magnitudes together. That'll be an annoying task to find a 3 by 3 matrix like that. I don't know exactly how you would do that. Without like Graham Schmidt, that we haven't learned yet. Or that, Graham Schmidt is in 4.4, this is 4.1. I feel like I know theoretically why. Let's just look at what he says for the answer. Yeah. Yeah, I don't care about lines. Why is each of these false? Um, you can put it in math discussion. It might make you go through like some annoying steps before it lets you post, which I wish I could take that off. But just like if it makes you like look at certain things or do certain things, just like try and click through it. That works too. Yeah, you can make a new post in there in homework help. For part A, um, planes have to have a component at least a component of their subspaces be parallel, because they always intersect in a line. Um, in Le Chiffre, yeah, what we can do is like in math homework help, just do like new post, and then you can post something in there. Like it'll just like it'll make you put a title and use like an image inside there or something. Whatever's easiest. Or if you want, you could just if you want to avoid that too, even just go to math discussion and put it there. It's not that strict. Let me clean up some of these tabs. I have too many open. Here we go. Okay, they have to have at least a perpendicular component. What's in part B? Huh. Um, well, the thing orthogonal in in 5 dimensions, if you want to be orthogonal to a two-dimensional plane, surely if you want every orthogonal direction, which is what the orthogonal complement is, surely you need three things. That's why I'm saying B is false. Two subspaces that meet only in the zero vector are orthogonal. That meet only in the zero vector. What's your question? Okay. Curl of the divergence. Ooh. This is a really neat question that I need to figure out the intuition for. Is the curl of divergence always zero? No, isn't that the curl of divergence is something, isn't it? It has a different name. I'm trying to remember from E and M. Divergence of curl is zero. Curl of divergence. Um, I really like this. I don't know how you do it though. All right, I don't know offhand. Like, can we figure out, like, what does this mean? I'm just a little bit rusty on curl and divergence. I know I can eventually figure this out. Um, I seem to remember like how you would tell this without doing calculations, and I need to go soon. Crap. All right, Shifra, I'm sorry. I do have to go. I can get back to you on Discord though, if that's okay. I'll keep on thinking about this. Or if someone else wants to take a stab at it, it is posted here. I'm trying to remember the intuition for this, and I don't remember it offhand. I know I can figure it out. But it's gonna take me a little bit of time. Yeah. Wait, is Zach already live? Oh wow. I didn't realize he was already live. That makes my life easier. Hey Reaper. Um, I'm just about to end the stream, so I'm sorry this is bad timing. I hope you're doing well though, dude. All right, so um, let me type a message to the shipper in case they're on a delay. Hey, Kazmi. Uh, okay, so I'm gonna do the YouTube stream off here and raid into Zach. Um, thank you everyone for being here, LeChiffre. I will get back to you. I'm sorry that I can't figure it out quickly, but I do have to leave. So, Kazmi, hi and bye. Sorry you caught me at a bad time. I'll see you later, YouTube.